of course, the research didn't stop. They found more particles. They were called kaons or K-mesons, and they found these tracks. The tracks come from here, and then you see this V here, and they were two pions, a negative and a positive pion. So that was a very strange track, these V-shaped tracks. And they found another particle, must have been here, the K-meson. And why a K, or why a kaon? Well, basically because when you look at some of the tracks, some of them produce 3 pions, and it looks like this. So the kaon comes in here, and it shoots off 3 pions in 3 different directions. So they saw these, well, they had tracks like these many times, so they thought, oh, let's call the K particle a kaon. Okay? So that's nothing very fancy, but it has to do with what they saw. And it continued. We found more particles. They did a similar experiment. We see all kinds of tracks here. This is the simplified version of that. Here is a pion. It decays into something that we can't see. That's a neutral particle. And then it decays again in 2 tracks. You see them here, charged particles. And then there must be some particle here connecting, because you see something starting here, a negative and a positive particle, so this must have been neutral again. They found this Lambda-baryon. Now it's called a baryon because it's a heavy particle. They saw the mass. Look, these are the kaons in between masses, and this is even heavier than a proton. So they call this a baryon. It's just a name to describe it's a heavy particle. There are more properties that are a bit too difficult to explain now, but basically it's a heavy particle. These particles were produced very fast, but they decayed very slowly, which was strange. Usually they found that massive particles, they decay fast. And these had a longer or a shorter lifetime, a longer lifetime than you expect. And there was a big difference. Basically they were produced in 10 to the minus 23 seconds, very fast, and they decayed over a relatively long time, 10 minus 10 seconds. So that's a very short time, I know, but it's 10 to the 13th, so 10 billion times longer, 10 trillion times longer than the time it took them to produce. Now, that is a difference of being produced in 1 second and then staying alive for 300,000 years. That's a very big difference. So these particles, they acted strange. And this strange thing, you will see later. It didn't stop there. We found even more particles. So they found the Xi-baryon, the charged particle first, later the neutral particle. It decayed into these particles, and it just continued. Masses, heavy, right? Heavy particles. And they were found to be only 2 members of a large family of particles, also in a relatively long lifetime. So, that's it? No, that's not it. More particles. So, they found delta-baryon, sigma-baryon, just names, but they found all these heavy particles that nobody knew what to do with, nobody needed. Still they found them. And it was called the age of the particle zoo, because there were so many particles that nobody ever heard of or found or whatever, and they didn't know what to do with them. So that's very strange, but the solution was around the corner, because a couple of physicists had the idea, let's call something, this property, let's call this strangeness. That has to do with the long lifetime. And it actually was a step in the right direction. We found later.